Okay, today 7.6 quadrantal angles. So these are angles whose terminal side lies on the x or y axis. So they just end up on a quadrant. For example, 90 degrees. If I asked you to graph 90 degrees, it would end up right here. Yes? All right, great. Then 180 degrees ends up on the negative x-axis. 270 gets you all the way down to here. And then 360 gets you all the way back to where you started. So let's do these angles in radians real fast. So keeping in mind this is pi, if I go halfway, that's pi over 2. So 90 degrees in radians is pi over 2. We already know 180 degrees is pi, so that's here. We know that, we're skipping one, 2 pi, which gets you all the way back, is here, and that is 360 degrees. And then this guy right here is 1 pi and a half a pi, so that's going to be 3 pi over 2 is the same as 270 degrees. Now how the heck do you evaluate these? That's the question. So the way that we evaluate these guys is by actually using the unit circle, which we've been studying for the past 2 days. So if this is a circle and it's a unit circle, the radius is 1, and because I'm in the positive y direction, if this was on a graph, which we'll pretend it is, that would be the point 0, 1. So right here, this is 0, 1. Then, if I go to do this one, what would this point be if it were on a graph? It would be negative 1, 0. The x is negative 1. If I went all the way down here, now the y. So 0, negative 1. And what about this guy? If I go all the way around, or even if I just stay at 0, that's the point 1, 0. So at the top of your paper, what I want you to write down is what we've been kind of practicing all along, is that the sine of an angle is equal to opposite over hypotenuse, but there's no triangles here. So it's really y over r. And keep in mind, when you're on the unit circle, the radius is always 1, no matter what. The cosine of an angle we know as adjacent over hypotenuse, but we've also been practicing it as the x-coordinate. And then the tangent of theta is going to be O over A, and O is equal to y, and A is equal to x. Okay? So we're going to be using these guys because we don't have triangles, so opposite over adjacent, hypotenuse, that doesn't make sense when we're dealing with quadrantals. We don't even have triangles, we just have points. So if I ask you for the sine of 90 degrees, what you're going to do, just like we've done all along, is first step is to graph the angle. Don't try and make a triangle if you land on the axis. What you're going to do is label that point. You're like, okay, so sine is equal to y over r. Miss Wolkin says, because we're on the unit circle, not just Miss Wolkin, math says that because you're on the unit circle, the radius is 1 unit, so it's 1. What's the y coordinate here? So the y coordinate here is 1. What is 1 divided by 1? 1. So you could even punch this into your calculator, make sure you're in degree mode, but if you type in sine of 90 degrees, it'll tell you it's 1. Tangent of 270. So 270 gets us here. So we're on the quadrant, so we're going to label it with the appropriate unit circle point, 0, negative 1. Why is it negative? Because we're down. And then tangent is going to be y over x. Why is it y over x? because it used to be opposite over adjacent, and opposite was always the height of the triangle, and adjacent was always the base. So this just makes sense. Y is like a height, it's vertical, so, and then the base would be x. So we are going to take our x and our y and plug it into the right spot, but uh-oh, you can't divide by 0 in math, so this one is undefined. There is no value there. Next one, cosine of 240 degrees. So 180, 240, what? That doesn't end up on the axis. So what do? Well, this has a 60-degree reference angle. So then we go back to our special triangles that we've been learning. Opposite 60 is always root 3 over 2. In this case, they're both negative sides because of the location of the triangle. Cosine is x over r, or adjacent over hypotenuse. So we have -1/2 over 1, which equals -1/2. Moving on to the next one, cosecant of -90. So -90 is here. I'm still down in the negatives, so it's 0, -1. Cosecant goes with sine. Sine is y over r, so this is r over y. The radius is always equal to 1 on the unit circle, and then my y value is equal to -1, so the cosecant of -90 is -1. Alright, moving on up. Tangent of 225. Okay, if you're looking over here, do you see any 225s as a quadrantal? Do you see anything that ends with a 5? No, so it's probably not going to be a quadrantal. 225 is here. It bisects this quadrant, and I've drawn it beautifully, so that lets me know that I'm dealing with a -√2 over 2 and a -√2 over 2. So those are my angles. So tangent is y over x, so it's going to be -√2 over 2 over -√2 over 2, and that equals +1. Okay, cosine of -540. I'm not sure if this is going to be a quadrantal or not, so I go -36 or 360, 45 or 450, and then the next one is 54. So it is a quadrantal, and that point is -1, 0. Cosine is x over r, so it's going to be -1 over 1 because the radius is always 1. You don't even see it in the point, but the radius has a distance of 1 no matter what. Alright, tangent, we're doing radians. Tangent of pi. Pi is here. This is the point -1, 0. Tangent is y over x, so this is 0 over -1, which is 0. So sometimes it'll be 0 and sometimes it'll be undefined. Friendly reminder, it's okay to have 0 in the numerator. It is a big no-no to have 0 in the denominator. Okay? So we were in this situation here. Cosine of 2 pi. 2 pi is there. That is the point 1, 0. Cosine is x over r. Radius is always 1. Cosine is 1. Or the x value is 1, so that's going to be 1. Secant of 7 pi over 2. 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2. I don't know why I drew that spiral so big, but I did. It's great. So this is the point 0, -1. Secant will be r over x because it's cosine, so it would be x over r. So this would be -1 over 0, which is not okay, so that's undefined. Cosine of, or cotangent of 13 pi over 6, that's 2 and 1/6 of pi. 2 and 1/6 of pi is 1/2 pi. 2 and 1/2 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 of pi is 1/2 pi. 2 and Oh, beautiful. Not even a quadrantal. Good thing we have to do this. Cotangent is going to be x over y because tangent is y over x. So x will be root 3 over 2. Y will be 1/2. And then we are going to do root 3 over 2 times 1/2. Wait, it already says 1/2. I didn't flip that. Do you see that? So it's 2 over 1. Which those reduce, so that's just root 3. Second to last one, tangent of negative pi over 3. Negative pi over 3 is going to be a 60-degree reference angle. 1/2, 1. This is going to be negative root 3 over 2. Tangent is y over x. And because this is a triangle, if you want, you could actually do opposite over adjacent. Negative root 3 over 2 over 1/2. I feel like we just did this. It's totally fine. So that would be negative root 3 over 2 times 2 over 1, which is negative root 3. Now, I put this one on here for a reason. Cosecant of 3 over 4. So, first of all, there's no pi. So, even though there's no pi, there's also no degree symbol. The default mode would be radians. Okay, so radians. But what does 3/4 look like? It's not like pi, it's not 3 pi over 4, it's just 3 over 4. So if we wanted to evaluate this one, we would have to use a calculator because this is not a special triangle. Okay, so this is not a special triangle angle. So we would need to use a calculator. We would do 1 over the sine of 3 over 4 if we're plugging that into our calculator, because our calculator doesn't have a cosecant button. Sometimes students think that this button is the cosecant button, but it's not. That's actually sine inverse. We'll be using that later. So the cosecant button doesn't exist. So you do 1 divided by sine because cosecant is the reciprocal of sine. So that's how you do a reciprocal in math. And then you'd make sure you were in radian mode, and then you would get your answer. We don't need to do that. I'm not going to test you on it, but I just wanted you to be aware that it really is important that you're looking for these special triangles. They're not everywhere in the world of math. These lessons are rigged because we want you to understand them, but it doesn't always happen. So that definitely would have to be on a calculator portion of your test. And that's it.